Morning, everyone. Welcome to this Process Safety with Louise. I hope that the morning finds you well. I'm going to start with the introduction and we'll go on to safety moment. And then after that, we will open the floor for questions. So I have already some questions from YouTube, from LinkedIn. So I'll share those when we get going. So this is just a reminder. Please be mindful of what you say and be respectful. The sessions are being streamed live to YouTube and will be available for playback. And everybody here is providing their time free of charge. So what is this session? It's a place to get access to industry experts and ask questions on specific topics once a month. This month obviously is at 7 a.m., but we run them 7 a.m., noon and 8 p.m. And it's available for catch up on YouTube. And it's a place to share best practices so we can all learn from each other. And for those of you who don't have a support network, you have somewhere you can come, you can ask questions. So welcome to Process Safety Forum for July. We should be having Lorraine join us very shortly if she hasn't already. And Lorraine is a human factors specialist and will be able to help us answer any questions about human factors. Right, so we're going to go for a quick introduction and then a safety moment. What I'm probably going to do is the safety moment first, and we'll move the introductions to after that to allow people to join. I'm then going to open the floor for questions and sharing, and then we'll wrap up at about 10 to 8. Okay, so I'm going to end this now. I'm going to pop on the safety moment. Hi, Lorraine, nice to see you.
Hi there, Louise. Thank you.
All right, I'm going to play the safety moment. We can turn the videos off and then we'll come back for the introduction after.
Okay.
So we're just moving on to the safety moment now, guys. Going to share the screen.
April 2nd, 2010, the Tesoro refinery in Anacortes, Washington. A nearly 40-year-old heat exchanger violently ruptures, causing an explosion and fire that kills 7 workers, the largest loss of life at a U.S. refinery since 2005. The Chemical Safety Board launched an investigation and determined that the heat exchanger catastrophically failed due to long-term damage from what is known as high-temperature hydrogen attack. The Tesoro refinery in Anacortes is an 800-acre facility located approximately 70 miles northwest of Seattle. The refinery produces a variety of products, including gasoline, diesel, jet fuel, and asphalt. Within the refinery's naphtha hydrotreater unit, raw naphtha, a light component of crude oil, is treated to remove nitrogen, sulfur, and oxygen impurities. Before entering the unit's reactor, the raw naphtha and hydrogen are preheated inside pressure vessels called heat exchangers. The unit contains 2 banks of 3 heat exchangers supported by a 3-level steel structure. Each heat exchanger consists of a bundle of tubes inside a steel shell. Hot fluid exiting the reactor flows through the heat exchanger shell, while cool fluid headed for the reactor flows inside the tubes. Heat is exchanged through the walls of the tubes. Every 6 months, the heat exchangers are taken offline to be cleaned because of fouling, a common occurrence when operating heat exchangers in this type of service. As the raw naphtha is heated, a scale-like material forms and deposits onto the inside of the tubes, hindering the transfer of heat in the exchangers. On March 28, 2010, 1 bank of heat exchangers was taken offline and disassembled for cleaning, while the other bank remained in service. This allowed the unit to continue to operate. By mid-afternoon on April 1st, the cleaning was complete, and operators initiated the startup of the offline bank of heat exchangers. The procedure required an inside board operator monitoring the control console and one outside operator opening and closing large manually operated valves. But the heat exchangers had a history of developing leaks during startup, something that refinery personnel had come to see as normal. Additional operators from other nearby units were called upon to assist with the startup, including mitigation of potential leaks. By 10:30 p.m., the outside operator was joined by 6 workers from other units within the refinery. The 7 workers were located around the heat exchangers, where startup activities continued past midnight. But unknown to the workers, the steel shells of the middle vessels in both banks of heat exchangers had been severely weakened due to cracking caused by high-temperature hydrogen attack. This occurs when tiny hydrogen atoms diffuse into steel at a high temperature, then react with carbon in the steel to form methane gas. The larger methane molecules, unable to diffuse out of the steel, accumulate, stressing the steel and over time causing fissures. In both of the middle heat exchangers, the fissures grew and connected to form large internal cracks. One such crack was 48 inches long and extended more than 1/3 of the way through the vessel's 1-inch thick shell. Shortly after midnight, the temperature of the fluid exiting the tubes of the online bank of exchangers increased about 75 degrees over the span of 3 minutes, a temperature increase that was typical and observed in previous startups. But the middle heat exchanger was so severely weakened from high-temperature hydrogen attack that it likely could not withstand the stress caused by the rapid temperature increase. At 12:35 a.m., employees working at a nearby process unit heard a loud hissing noise when vapor began to leak as the heat exchanger cracked at its weakest point. Seconds later, the exchanger violently ruptured. Hot hydrogen and naphtha vapor rapidly vented from the exchanger and spontaneously ignited upon contact with air, resulting in a massive fire that consumed the heat exchanger structure. 3 of the 7 operators died at the scene. The other 4 operators were transported to local burn centers with severe injuries. 2 died within hours. The other 2 succumbed within days.
So welcome back. I don't know if you've all seen that before, but sorry, I'm just pausing my screen. But that was a very significant incident in the US, as you saw. And the human factors element of that was, did we really need 7 people changing over that exchanger? Because this was such a frequent occurrence, could we as engineers have done something to make lives easier for the operators? Lorraine, what are your thoughts on that?
You just started. Yes, I think like most things, you know, if you can keep people out of the area, then clearly you've got less risk to the people. I think it's sort of fairly natural that people will come to assist their colleagues if they see that they need help. And I think often it's about understanding what help can be provided, because often people just tend to congregate to watch a few people working. There's the classic video around the tanker leak. I forget the scenario now, but you know, you had lots of people just coming and watching a leak and an incident develop. And I think sometimes it's about providing some guidance to people about what the behavior is that's expected when these sort of things go wrong and how to manage it. Yeah,
and that's where the drilling, like drilling the measures really helps.
Yeah, absolutely. I think if you go through those, it's like your emergency response practices, isn't it? That you know, you go from that state of not knowing what to do to actually, by drilling it regularly, that the alarm goes off or whatever it might be, and then it becomes quite instinctive, habitual behavior to do the right thing because you had plenty of practice at it.
Yeah, that's right. I'm going to do the quick introductions. Just we've got quite a few people on the call, and I just want to make sure that they both know who we are. So I'm sure that you guys have joined these sessions before. My name's Louise Whiting, and I host these sessions. I provide process safety services through Barberton Limited, and we run these sessions to answer your questions for free so that you have access to people who can help you, even if you are not living in the UK. And today we're joined by Lorraine, just for today. So Lorraine, if you can give a quick introduction to yourself.
Hi, so I'm Lorraine Braben. I'm a human factors consultant. I work for myself. So the sort of work that I do is around providing human factors consultancy services around the process industry. Mainly it's been in the UK, and I tend to do a lot of work with the high hazard sites. So that's sort of auditing assessments, do a lot of project work around all of the various human factors topics, and also training and mentoring for people to get them up to speed around what the expectations are around managing human factors. My background is chemical engineering, so I'm a chartered chemical engineer, worked in the process industries for over 30 years now. I also, I moved from engineering over into HR and got my qualifications in that. So I sort of fell into human factors as a result of that background when the site I worked for needed somebody to pick up that with having that technical background and that people management process. So I've been involved in human factors for about 11, 12 years now, something like that. And I've been working for myself for over 4 years.
Excellent. And I know that a lot of the time when you get involved with sites, it can be because the regulator is visited, is that right?
Yes, I think a lot of the time what I see is people tend to have an idea of what human factors is about, but not really the technical level of knowledge that's required. And certainly in the UK, the regulator is pushing, for sites to get started on human factors. Generally, I see a lot of work starting around identifying safety critical tasks and then getting into task analysis of those tasks. And often that's been prompted by legal actions. So I tend to get involved in sort of helping organisations start that journey and close out those actions and develop a plan to sort of progress beyond the just satisfying the regulator. So
I see. Yeah, I think what I've seen is that if you use human factors properly, i.e. to manage risk rather than tick box exercise, it's really useful. But if you're just trying to use it as a tick box, it's like anything, it doesn't really add value.
Yeah, I think that's right, because it's like everything, you have to put quite a lot of time and effort into working on this topic, and it's such a wide-ranging topic as well. If you're only doing it as a tick box exercise, i.e. closing off actions and then not really seeing it just doesn't work. It doesn't work for the site. The resources are wasted. What you really want to do is to engage with people and help them to learn and move forward. And what I've seen is, so for example, I've been doing some work on a site over the last 2 days, and we were working with one of the operators doing a task analysis. And at the end of those 2 days, he's like, "You've just opened my eyes to all of the things that, are going on in my world. Having spent 2 days unpicking this particular task and asking questions and just understanding what the risks are, and risks that people tend to just become quite complacent about, because you're in that environment all the time, so you're not really questioning yourself. So I think by going through these processes, not only does it actually reduce the risk in terms of the management process, but it also really educates the people involved around what human factors are, where human error can come along, where it can catch us out, and how we can actually manage those. And those actions that we can put in place to reduce the risk are often really, really simple, and can be ever so effective at reducing the risk of error.
Yeah, a lot of the feedback I get from clients is that they think that if we go through more risk analysis, the solution is going to be super expensive and really complicated, and we're going to have to remember how are all these things we're going to remember. It's never going to work. But it's really good to get that feedback that human factors is not necessarily something we've got to spend money on, and it may just be a different way of doing things. Is that right?
Yeah, absolutely. I think, you know, we tend to think, when we think of some of the topics that come under that human factors banner, they are often things that companies are doing anyway. So we think about training and competence, we think about writing operating procedures, for example, or having effective supervision. All of those make a real impact on the day-to-day work of, you know, people on the ground floor, the shop floor, and they we're doing it anyway. So let's just do it in a slightly different way. You know, it's not going to cost us any more money other than maybe making those adjustments at the beginning, understanding what it is that we can change and tweak and improve. And then we see the benefits because we're doing it anyway. So it's, you know, most of the recommendations we make when we go through these sort of processes tend to be relatively low level. So, you know, it's not really about the money. It's about having the time to actually look at these situations and just, like most things, unpick them a little bit and really look closely. And then you start to realize that there's some very quick solutions that you can put in place.
Yeah, I think really once you start to understand what the hazard is and what can go wrong, you can put something very targeted in. Whereas if you're just trying to, you know, think about all hazards, you start solving more in peace. But you really understand what it is you're trying to solve and what could go wrong. That's the key, isn't it?
Yeah, absolutely. I think that what I tend to see is people sort of are either, well, generally human factors is there's so much that can go into affecting human behavior. And often I see people going, well, you can't predict what people are going to do, can you? And, you know, because people are people and we all do these random things. But actually, when you start looking at it, you know, a lot of our behavior is predictable. You know, if we think about the influences, the signals in the environment, they affect our behavior and actually drive us into a certain way of acting. So if we haven't got the right tools to do a job and there's a pressure on the time, there's a good chance that some people will try and make do with whatever tools they've got available to them. You know, it's not rocket science.
Yeah.
You know, it's common sense in some respects, although I don't really like to use that term because it's not always that common. But, you know, you can see that if we don't provide the right tools, then potentially people feel under pressure and therefore make, you know, effectively decisions that are probably not the best in the circumstances, you know, and these are not difficult things to see once you actually start getting into the detail. I think often it's the time required to do the analysis that puts people off, because you do need to look at the detail, because often it's those small details that subtly influence us rather than, you know, just having a wide look at something. You miss a lot of that.
Yeah, that's right. I had a question on LinkedIn, so but it's not human factors related. So I'm going to share my screen, answer that, give you a chance to read the Q&A that's come in, and then I'll come back and ask you those questions, okay? So the question I had on LinkedIn was, what is the difference between an isolated volume for the purposes of blowdown and then what's a node, and how do these two things relate, and how can I reduce my risk associated with these things? So I thought a good example would be to bring up a distillation column. So for example, this one here, you can see you've got some valves on each stream. If we're thinking about a blowdown scenario, or what we would look in the QRA as an isolated volume, we're likely to look at from this valve will close, this valve will close, and this valve will close. And so this here will form our isolated volume. Okay. So when we're looking in the QRA, we're looking at which automated actions or which physical arrangements, for example, non-return valves, will result in us having an isolated volume, which then needs to be reduced in pressure or protected in some way to prevent an overpressure in a fire scenario. When we're looking at nodes, nodes are coming in from HAZOP, and nodes don't actually mean anything in the process, really. They're just ways in which we break down the system so that we can look in more detail, like Lorraine said, and really understand what's going on. So for example, here, if I'm looking at the same system, I might actually do 3 nodes for the column. I do the liquid in with the liquid out. I would do, if there's a gas inlet stream, I'll do the gas in with the gas out. And then we might do some hold up in here or something around the reboiler. Okay, so that's the difference between nodes and isolated volumes. Nodes don't actually mean anything associated with managing the safety. They're simply a convenient way of analyzing the system, but isolated volumes are the way in which you are reducing inventories around your facility to help you manage the risk. Okay, so I've had a question here from Mohammed. Why mostly oil and gas industry bypassed main ESDV is not controlled by the control room and a manual call point in case of emergency or major gas industry release? Lorraine, is this something that you want to answer? Do you want me to take?
Yes, could you just repeat the question again then, please?
Okay, so in oil and gas industries, there's a bypass around the ESDV, most typically, but it's not controlled by the control room or a manual call point in case of an emergency or major gas industry release.
It's not something, because I've not worked particularly in oil and gas, although I've done some work for oil and gas, but that's not my background. I think, so when you're saying an emergency shutdown valve, yeah. So I think often it's about practicality, and what I've seen is a lot of the plants are designed, you know, a lot of our facilities are quite old, to be fair, and some of the impacts on the way in which people interact with them were not necessarily considered at the design stage, and so often we're left with legacies around the design on these things. I would imagine, without knowing the background context, the bypass is there, you know, from a practical point of view. Now, whether it should be there, I think depends on the context, on the process. And the other question that I would have is, how is that actually controlled? You know, how do you control that bypass around the system? Is it locked off? Is it something, you know, that people are allowed to just interact with? You think of the for most of plastics incidents back in 2005, and the safety bypass connection, the emergency air connection, you know, just because it's there doesn't necessarily mean that it should be used, I think is my opinion of it. But I can see that a lot of these things are legacy issues.
Yeah, I mean, in my experience, the main reason for having a bypass around the ESDV is for startup. So you don't want to be operating your really expensive valve across a high differential pressure. But in the newer facilities and the facilities I've worked on, most of them, the bypass has the same level of protection as the ESD. So it has position indicators, and it also has ESD action. So if the main ESD valve is supposed to close, that one closes as well. But I can imagine that there are several facilities, as you said, legacy facilities, where the bypass is in manual. This can be really dangerous from the perspective of overpressure. So many times the system downstream, it's only sized for the ESDV failing open. It's not sized for the ESDV and the bypass to fail open. And so as a result, you're completely unprotected if you leave the bypass open. So definitely having, like you said, really good controls. If you identify the risk, you know what could go wrong, you can then identify some good controls, like you could lock it closed and only have certain times when you can open it. It needs to only be open for a certain amount of time. Obviously, if it's a manual bypass and you have an ESDV event, it's it's going to cause trouble, because you're not going to send somebody in there to close
Yeah,
it.
yeah,
But
absolutely.
if you can put the actuation on with the position indicators, that's really, you know, it removes the human element of it, doesn't it?
Yeah, yeah, that's right. And I think, you know, there's an acceptance that these things exist. I mean, clearly, if we've, you know, there's normally a reason why it was put in the first place. And I think for me, it's about understanding what those reasons are, because I've certainly had examples, not with that particular scenario, but with others, where where there's been things that have been put in place for a reason, and then the reason for that knowledge almost mutates. The reason for that installation mutates over time as people move on. You know, we're not very good at retaining knowledge in an organization. Knowledge sits with the people. And so another sort of quite crucial part is about how we actually document the reason for some of these design features, and what they're there for, and how they should be controlled. So that knowledge gets retained in the organization and doesn't move into, you know, a myth of something else.
Yeah, that reminds me of also in projects. So often in the concept stage, you spend loads of time putting things in the right place, and you have really good reasons, you know, maybe you can have a jet fire or whatever. And then you get to detailed design and they just go, okay, well, we can move this, but they don't realize the reason why you left them there, because you didn't tell them, right? You didn't tell them very well why you put it there. So yeah, it's really important to keep that communication going, and the reasoning behind why you've done it.
Yeah, that's right. And I think, like you say, there's always a reason why something gets built. You know, it wouldn't have been built if there wasn't somebody who thought about it and put that in place. But I think this idea of organizational memory is quite an interesting one. And even, you know, I've experienced, having worked for an organization for over 20 years, I've had experience where I've been involved in plant design and it's been documented in the technical manual. And then 10 years down the line, that manual isn't even being referred to anymore, or it's been archived, or, you know, no longer seen as being relevant. And yet there's information in there that is pertinent to how the plant has been designed and that could have an impact in operations. And I often think that it, you know, sometimes people get so caught up in the day-to-day stuff that it can be very difficult to have the time to go and read some of the background information. And so sometimes it's about how you take that knowledge and understanding and make it much more available. You know, because it's not, you know, when you're busy, it becomes a nice to do rather than a must do, doesn't it?
Yeah, and also having your own personal copy of the procedures and then not updating it. All of those types of things. I've had another question here. Are there any regulations that for human factors engineering, or any international standards for human factors?
Okay, well, it depends what you mean by human factors, because, as I say, it's such a wide-ranging topic that there are standards for different elements of it. So in general, I think ISO 11064 is probably the key one for thinking about ergonomics in design, and that's got a lot of useful information in it. There's also things like EMUA, I was getting the numbers mixed up on these two. So things like EMUA 201, which was updated fairly recently, which is specifically around design of control room. And you've got EMUA 191 for alarm management systems. So yeah, it depends what it is that you're looking for. I think because really human factors is the topic of how people interact with their environment and fit in, you know, that environment to make it work for the person. It depends what specific part of the environment that you're wanting to see to work on as to what regulations then become relevant. So that's just a couple of examples that we would look at. But again, they don't cover the whole world of human factors. They cover specific elements of it. So it's understanding just what part of it that you're interested in.
Yeah, Adi, I don't know if you can give us a little bit more detail about what parts of human factors you might be looking at. There are obviously parts, because you said you get involved after the regulator visits. There are obviously parts which are regulated, but if you can give us a bit of clue which part you're looking for, that would be helpful.
Yeah.
I've had a question from Gemma. This is relating back to the bypass valves. So physical coloring of the valves and classifying the bypass valve as safety critical. So the bypass valve would definitely be safety critical if it is associated with overpressure protection sizing downstream. If having the bypass open means that you're going to overwhelm the overpressure protection downstream, or overwhelm the liquid handling, or overwhelm that gas handling, then the bypass valve becomes safety critical, and then it requires to be locked in a position, whichever position there is. If it doesn't have any impact and those systems are fully sized, then if you leave it open, what are the consequences? And then we're getting down to what we were talking about with the isolated volume. If the bypass doesn't close, does that cause you a major issue with escalation from one part of the facility to another? And again, if that does cause you an issue, maybe there's a very high pressure source and a low pressure source, then again, it becomes safety critical. But if again, it doesn't have any consequences associated with that, because maybe there's isolations further on, again, not safety critical. So I don't know, what are your thoughts, Lorraine? Is that how you guys approach identifying the safety critical tasks and equipment in the human factors?
Yeah, I would say that generally I agree exactly what you were saying there, Louise. It's about understanding the context of that valve and what impact it has on your, hazardous consequences. So personally, I don't tend to get too involved in the identification of safety critical equipment. Often I will get involved in safety critical equipment in terms of the tasks that's done on it once it's been designated as safety critical. So what I tend to see is different organisations have different ways of designating what equipment is safety critical or not. So and what I found quite interesting is that a lot of organisations have already gone through the process of identifying safety critical equipment, and then I get asked to come in and identify the safety critical tasks. And there's sometimes quite a disconnect between the approach for one and the approach for the other. It's not always quite clear to me that safety critical equipment is directly associated with those major accident hazards in the same way we tend to identify safety critical tasks. And that can make it a little bit difficult sometimes in terms of understanding how the two work together, because there should be a common basis, which is
a direct mapping.
Yeah, which goes back to what you're saying, which is it should be safety critical if there's a risk associated with that hazardous scenario, and that applies to both tasks and equipment. So that's it, my only comment. But in principle, I would agree exactly with what you were saying on that one.
I have found that especially with safety critical equipment, not everybody understands what the equipment is there for and why you would use it. But then all of a sudden you check this list of safety critical equipment, you go, oh, I have one of those. It better be safety critical. Oh, yeah, I got one of those. So then you list all these things as safety critical. You don't actually know why they're safety critical, because they probably aren't on your design. And you have all these things as safety critical, and then you come in and you're going, it's not matching. So yeah. I've got a question about safety critical task analysis. So is there any guidance to help people with safety critical task analysis? Where can they start to have a look for things?
Yeah, I think there's a lot of information on the HSE's website, but I think probably, at least in the UK, the standard guidance is the Energy Institute's safety critical, their guidance on safety critical task analysis, which was updated and republished January last year, and that's available on the Energy Institute's website. I'm just trying to think if I've got any references to it, but I might have to just look it up.
Yeah, well, I've written those two down, and we send out an email afterwards to all the attendees, and I'll pop those two links in once we've got them.
Yeah. The Energy Institute is their guidance is really comprehensive, and I think that's probably as good a starting point as anywhere. That would be the one document I would direct people to. And if you want to read a little bit more around it, then I would suggest that the HC's website has got a lot of information under topic 1 of human factors. Under topic 1 around human performance. Okay,
we've had another question. This is relating back to the regulations. So, for instance, if human factors assessment was to be carried out for the incident in the video we watched, what human factors related standards would be referenced or used for such an assessment? I know the incident happened in the US, but if it did happen in the UK, so what sort of thing would we be looking at? What would people be prosecuted under?
Okay, well, I would imagine, because it sounded like the root cause of that was around the hydrogen impact on the weakening of the structure. So clearly you've got some sort of inspection type issues associated with that. And from a people point of view, what sort of would be coming out of my mind in terms of the human element of that is, why were there so many people in the area at that point? Was there an understanding around the failure mechanisms for that type of equipment? Was the way in which they were starting up appropriate? Was because of that sudden temperature increase, did that increase the weakening of the vessel? There's a number of things there. Now, when you talk about the standards associated with those things, not all of them would come under a formal human factors standard. Some of them will come under your design standards for the equipment. And a lot of that is then about, when you understand the design standards, the normal engineering standards, is about how you interpret that to get the risks into the heads of the people who've got to actually operate it and inspect it. And that doesn't really come under a standard per se. It's not like there's a human factors standard that says, if you've got a heat exchanger, this is what the humans need to do with it. It comes under the general design engineering standard for that type of equipment and pressure systems and so on. So what I would say is that, you've got standards around inspection, and most of the human factors work is about understanding the baseline engineering standards or practices, so things like pressure safe, the pressure systems regulations, and working out what it is that people can actually do wrong that doesn't meet the requirements of those type of standards, if that makes sense. So yeah, I'm not sure that I'm really answering the question that was asked very clearly. I think that the key thing is to understand the standards that we're probably all familiar with, and then think about what people do to make sure that those standards are maintained. And that's the human factors part of it. Some of the guidance are starting to reference those human factors requirements these days, but that'll take years for them to come through and be updated and reflect that, I think, on the whole. So my advice would be, when we're looking at these type of issues, is just to go back to our baseline engineering and then think, how do I make sure that people do the right thing in association with this pit kit or this process, to make sure that it's managed, that we manage the risks, coming back to the points we've been talking about already. And I think that's how I would deal with that particular issue.
Yeah, I've also been reading another interesting document, which is the Competent Authorities Operational Delivery Guide for inspecting major hazard leadership. And in there, it specifically references that if your leadership, so potentially some of us on the call could be leaders in organizations, either directly or indirectly, if your leadership has impacted the way that people behaved, so for example, those people, it didn't say, but those people might have been under pressure to change over the heat exchanger online and make sure that they didn't have any interruption to production. Or maybe there was pressure on the maintenance department to complete the job quick. You know, you don't know what other pressures there were, but those types of pressures are actually something that the HSC are now actively looking at when they're investigating incidents, and they will start prosecuting against that as well, or putting enforcement in against that. So you know, it's really important, you know, even as a frontline or engineer, if you're an engineer, you're in a leadership position whether you like it or not, because you are influencing the behavior of the operators, and that can come back and
yeah, I think that's true. It's interesting when you know, we've just been talking about safety critical task analysis, that when you are getting into those analyses, often some of the things that come up are things like manning. You know, often manning's been reduced from when the plant was originally designed, the way in which it gets maintained, the way in which you know, the time that's available for people to do that job that is maybe a lot less than they did before, the fact that, you know, inspections get pushed out, or the maintenance window gets pushed out. All of those are leadership decisions that have a really direct impact on some very specific details in which people do. And I think as human beings, we're quite susceptible to those quite subtle influences. So, you know, what's said at the leadership level, what's said from, you know, your engineering group, they have an impact. And often we don't realise what that impact actually is. We think it's maybe a throwaway comment, but somebody can take that quite literally. And so we need to be quite aware of what we're actually instructing people to do. And the other thing that I often see is, you know, people will use a term for one thing meaning another, and it can be quite confused because that communication isn't as clear as it should be. And as soon as we open things up to interpretation, you can guarantee that different people will have a different interpretation of that, you know. And that's one of the advantages of going and actually observing what is being done in the workplace, because I see lots of times when you really look at it and you go, are you really doing that? Are you sure? You know, and you go in to observe these tasks. And I think that's the advantage of having somebody who's not particularly familiar with it coming in with a fresh pair of eyes and just asking a few questions that can make a real difference. Yeah.
Yeah, don't be afraid to ask those questions. I've got a question here from Andy. So manual bypass of an ESDV is a good example. Yes, we can challenge it to an actuated bypass valve, but then we have a more complex item that will need to be tested and maintained, which can have its own risks associated with it. Any thoughts on LNL? Is that learning and or how we can balance these types of technical versus human factors risks? How do you know you have chosen the best solution? I'm not sure, LNL. Andy, if you can give us an LNL. But basically he's asking us, how do we balance the decision between how complicated you make something so that it's automated, you're removing the human, to balancing it with the human being able to respond in a way that we want.
Yeah, I think this is where it becomes quite subjective. Clearly, if you've got some very robust engineering practices, then, you know, having something that puts a more complex task onto the engineering side of things, because you've automated that process to remove the risk from the front line, all it's doing is pushing it back at a level. But if those systems are working, then that's maybe the right decision. If, however, all you're doing is putting more pressure on a maintenance and inspection department that's already overloaded, then maybe it's not the right decision. Maybe, you know, you need to look at that balance to see what's appropriate. Generally, the principle is, if you can, you know, if you've got quite a complex system and there's a high risk of an operator getting it wrong, then ideally, if you can automate out that risk, that's got to be a good thing. But it doesn't remove the risk. It just moves it to a different part of the organization, because you've still got to make sure that that automated solution works on demand. And so you're looking at the risk of that. And there's no right or wrong answer in any of these things. It's just understanding where you're putting the risk and managing the risk. All of this is about managing the risk from the human being. It's just a different group of human beings that you're looking at in this instance. So I don't think it's an answer that you can say, yes, it's right to do this, or no, it's wrong to do it. It's all about the context and understanding that if you automate the system, then you need your resource in a different part of the organization. So you need to make sure you can provide that resource that's trained and competent and has got the time and the resources to be able to do that task, that maintenance type activity effectively. Because if you just load somebody else up, that'll be the failure point instead of the frontline operations. And, you know, it doesn't make a difference really. It's just a failure in a different part of the process.
Yeah, so I had feedback on what LNL is. It's Louise in the rain. So when I'm looking at any of these types of things, the first question to ask, as you said before, is, do you need the bypass? Do you need it? And what do you need it for? And then really thinking about how frequently you use it and under what scenarios you use it. If you only use it once in every 5 years, it's probably not worth all the maintenance effort to make it automated. You could lock it closed. If you use it once a week and it causes a significant process safety hazard, if it was left open, maybe in a shutdown, then you would be thinking about doing the automation. But it's really, as you've said, understanding what your hazard is, the consequences of it going wrong, and then also the frequency. So how likely is it you're going to be making a mistake on that thing, and then using that to inform your decisions about how much money you spend on that piece of equipment.
Yeah, and I think it's worth just adding in there, think about the impact of that, exactly what you were saying, the frequency of use. If it's causing people a problem, you know, it's adding time onto the process. You know, if it's you're starting up on a regular basis and you have to operate that regularly, then there becomes a sort of time saving associated with it. But actually, and I think more importantly, it makes it easier for the people operating that plant to get it right. And because if it's always a pain in the backside to do that particular activity, it's human nature to try and find an easier way to do it. And that's where often these shortcuts tend to come in, that, you know, often as engineers or managers, you tend not to be aware of what is really going on, because people are very good at finding ways that make it easier for them to do it. And if they're not aware of what that risk actually is by doing it in that way, you know, then why wouldn't they do it? Because it makes sense to them. So I think there's an idea of just understanding how difficult it makes it for people and how that then drives some of these shortcuts. And then combined with this idea of training and knowledge and understanding as to why that shortcut may or may not be appropriate, that actually adds an argument for changing it or not changing it.
Okay, I've got another question. What are the key points to focus on implementation of the process safety standard? But I've also got a question about how much credit we give human factor intervention. I think I'm going to ask that one because we spoke about this before the meeting. You know, I've seen people and you've seen people in Lopez, you're going and it, you know, 0.001275 is the those things are not helpful in these types of analyses. But I know you see that in the safety critical task area and that type of analysis. What is your advice for us on how to take credit for human intervention and make sure that we're not spending too much time doing the calculations and not improving the what really needs to be done?
Yeah, I think I tend not to get too heavily involved in human error probability calculations, because I think it's a bit of a minefield. And I think, like you say, you can spend hours working out the numbers and it's not making a difference to making changes and making the plant actually safer. So some of the advice that I've been given is, and this is really sort of caught up in the HC guidance around this. So, you know, if you came up with a probability of 0.1 to 1, not really going to be an issue. If you haven't done anything to safeguard or to prevent that human error, then there's a chance that it's going to be higher than 0.1. But, you know, in that sort of area, there's not really an issue. Once you start to go below 0.1 for human error probability, then really you need to be justifying why you think that risk of human error is being reduced. And so often that will be backed up by things like, you know, you've done task analysis, you've implemented the recommendations, so you've got robust training and competence procedures in place, you've got solid procedures that reflect what is actually done, you've, you know, optimized the process to make it work for the people, you've got effective supervision, and so on and so forth. And so if you could demonstrate that you've gone through that process, then you're down in the 0.01 type of probability region. When I queried this with one of the inspectors, the information I was told was that if you're going down to 0.001, 10 to the minus 3, then you're in the region of SIL2 trips. And think about the robustness of your systems to manage a SIL2 function. That's where you need to be to do that with your human being. If you're getting down into that sort of region, how are you going to justify that? And most of the time people can't. It's not just a question of, well, I think it's robust. You'd have to actually be able to demonstrate it.
Okay, so I've had a quick clarification that what we're talking about here is 0.1 with regards to the probability of failure on demand. So when you're talking about human, you're talking about, you know, 0.1 times that he does that specific task.
Yeah,
if he's doing that task very, very frequently, over a year's period of time, he will make a mistake.
Yeah.
Is that what you mean? Or are you talking about the frequency per year, like once it?
Well, frequency per event.
Yeah.
Per event. The other thing to bear in mind with this, because people will say, well, we don't see that level of error. And that's not to say that the error hasn't occurred, because often people will realize very quickly that they've done something wrong and correct it themselves. So just because there's been an error doesn't mean to say there's been the consequence, you know, because we have mechanisms in place to, you know, to pick up those errors. If you think about yourself typing an email, for example, and just a typo, and we all do it, we all see, you know, those errors, but do you send your email out full of those typos? Probably not, because a lot of, you know, most people will read through their email and pick them up before it actually has any significant consequence. So it doesn't mean to say that the error doesn't occur, even if it doesn't lead to that frequency of consequences as well.
Yeah, there are a lot of barriers in place, and a lot of people assume that because it's not happening, that it can't happen, which is not.
Yeah, exactly. Exactly.
Okay, so I'm going to just wrap up now. Thank you, Lorraine, very much for your time. It's most appreciated. I've had a really good session, and Gemma summarized it really well in one of the comments, saying that as an engineer leader, you need to give people two things. Number one is the physical tools, to be able to do the job, whatever those are, whether that's training or the actual mechanics of it. And then the second thing is to really help them understand the consequences of if they do it wrong. And that's each part, like we've spoken about, each part of the task, what can go wrong about doing that thing wrong. And generally, I found that people don't willfully take their hands into their, their lives into their hands all the time by doing things wrong. They just didn't realize that sort of bad things can happen. So what's coming up this month? We've got some courses on HAZOP, risk assessment and process safety. And our next session of process safety with Louise is on the 4th of August in 2021 at noon. So maybe not so early for us, but maybe accessible to another different audience. And then after these 3 sessions, we'll decide if we stick with one timing or whether we go carry on with this rotation. Lorraine, do you want to add any closing comments before we go?
Yeah, no, it's been really interesting to see some of the questions that have come through. Obviously, it sort of puts us on the spot this morning. So it's always a bit of a challenge, but I've enjoyed it, and thanks for inviting me, and thanks to everybody for your comments and your questions. It's been good. Thank you.
Yes, thank you very much. Everyone have a wonderful day.